Example A, classifying parallelograms, asks us what type of parallelogram are the figures below. So first one we have here is what looks like a rhombus and might be something else, might be a square. We can identify what it actually is by knowing, first of all, that all four sides are congruent. We have that marked. So we know that it is at least a rhombus. Then the remaining question would be, is it a square or a rectangle? Now, if it were a square or a rectangle, all four angles would need to be 90 degrees. In this case, we have at least one angle that's 135 degrees, which would mean that its opposite is also 135 degrees, and that these two other angles on the left and right couldn't possibly be that. That would be way too big. So this figure here just qualifies as a rhombus. And now our right-hand figure here, we have four angles that are all the same, shown as marked identical here. And we have one side that's 9 units long, and of course its opposite side would also be 9 units long if this is a parallelogram. And the other side is 5 units long, and its opposite is also 5 units long. So that means that this figure here is a rectangle. Okay. Example B. Example B asks, is a rhombus sometimes, always, or never a square? So a rhombus specifically has four sides. Well, first of all, it is a parallelogram, which means it has two pairs of parallel sides. And then if it's a rhombus, those two pairs of parallel sides all have the same length. Now those are both descriptors of a square, but a square also has four 90-degree angles. And a rhombus does not necessarily have to have 90-degree angles. So it can, but it doesn't necessarily need to, which means that a rhombus is sometimes a square. A square is a type of rhombus, but there are rhombi that are not squares. Take a look at example C. I saw this question, I thought, boy, I could really be a smart aleck. There's a lot we know about this square right here. I mean, we know it's white printed on, or black printed on white. We know it's in a book about geometry. We know I'm talking about it in a video. I mean, we could go on and on and on and on and on. But I don't think that's exactly what they were talking about. When they said list everything you know about the square SQRE, I think the point is that since this is a square, it's a parallelogram. And it's a rhombus. And it's a rectangle. And it has all properties of all three of those. So that means, of course, that the opposite sides are parallel. Let's get red so we can draw on that black and be seen a little better. That the opposite sides are parallel. Well, take 3. How about that? There, now the opposite sides are parallel. There we go. So SQ and ER are parallel. And then QR, I don't know why my little straight line thing isn't working. QR and SE are parallel. And we know that the diagonals bisect each other. So, and we know that the diagonals are the same because this is a rectangle also. We know that all four angles are 90 degrees. And we know that the angles on each side of the bisector must be 45 degrees because those diagonals bisect these 90-degree angles, so it cuts them into 45-degree pieces. We know that the opposite sides are equal. In fact, since it's a rhombus too, we know that all four sides are equal. So we know a lot of information about this figure by knowing that it's a square. And that's just kind of an example of it there. But basically, it has all the properties of a parallelogram and a rhombus and a rectangle. And that's about it.